Hello class, and welcome to lesson 6.5a. Today and the next lesson we're going to be focusing on applications of the quadratic relation. So we're going to be focusing on the different components or important parts of the parabola, like the initial value, which is your y-intercept, the min or max value, which is at your vertex, and the zeros or solutions by solving either using quadratic formula or factoring. But before we get to that, folks, let's take a look at our warm-ups here. It says to write in vertex form, and if it's from standard form to vertex form, there's three methods, but the easiest one is to complete the square. Okay, so ladies and gentlemen, we complete the square. We want to get a binomial square. So what we're focusing on doing this part first is the x minus p squared. Okay, so what we realize is in our expression in standard form, we want to take the a out of the first two terms. We'll bring the a out front. So let's do that. And we're going to ignore the plus 15 because he's not a perfect square, so he needs to stay at the end. He's kind of getting in the way, so we want to make sure we isolate him on the end. Okay, so we're going to common factor out an a, which is our 2 in this case, folks. So it's going to be x squared minus 4x, closing bracket, plus 15. Okay? So now what we're going to do, folks, is we are going to do our b divided by 2. So our b is -4, so -4 divided by 2 is -2. And then we're going to take that and square it. Sorry, I've got a little tight space here. So -2 squared equals 4. Okay? So 4 is the number I'm going to add, then subtract inside the bracket. So let's show that, ladies and gentlemen, and I'll put it in a different color, so just give me a second to write it in. Okay, so we always add it first and then subtract it after. Okay, keep in mind, ladies and gentlemen, the first three terms in our bracket are the perfect square, which we can take and make it a squared binomial. Okay, so we can do that first. Okay, so take the square root of the first, the sine of the middle, and the square root of the last, meaning the third term here, squared. Or the shortcut is, folks, it's right here, what you need to put inside there. Okay, now we've got to remember, folks, that we still have this -4 to deal with. And it is affected by the a, which is out front, so it's going to be -4 times 2, which is -8. Okay, and then we still have plus 15 on the end. The last step, ladies and gentlemen, is to collect like terms, which are these two here. Okay, so we go y equals 2 bracket x minus 2 squared plus 7. So what do we know here, folks? We know our vertex is 2 and 7. And in order to graph this, we also need to do our step pattern. So step pattern is based on a. So a equals 2. Therefore, our step pattern is 2 times 1, 3, 5. And that's going to equal 2, 6, and 10. So let's plot that, ladies and gentlemen. So we're going to find our vertex 2 and 7. So 2 and 7. Okay. From that, we're going to do our step pattern. As we go over 1, we go up 2. Over 1, up 6. 1, 2, 3, 4, 5, 6. And we can't go over 1 and up 10 because we don't have enough room. Do the same on the other side. Over 1, up 2. Over 1, up 6. Okay. And so that is equation A, or you can write it out, y equals 2x squared minus 8x plus 15. Now I want to show you something, ladies and gentlemen. We are in standard form in our original question, which gives you the y-intercept, so that gives you that point right there. So there's a check to make sure that your graph is correct. Awesome. Okay, let's take a look at the second question. I'm going to move it up. Okay, so the second question is y equals -4x squared minus 24x minus 20. Now, in the past, you would look at this and say, hey, I'd like to common factor out a -4 of everything. But we don't focus on that right now because we don't have 0 on the left side. We just have a y. So we're going to do our same steps, which is our first step is to take a out of the first two terms. So it's going to be y equals, we're going to take the -4 out of just the first two terms. Okay, so it's going to be x squared plus 6x, watch your sign there, guys, and then minus 20. All right. Now we're going to figure out, hey, what's this third term that allow us to get this binomial squared, the x minus p squared? So I'm going to do some work in the margin. I have more room here. That's good. So b divided by 2 equals 6 divided by 2, and that equals 3. Okay, then I've got to take that value and I've got to square it. So that equals 3 squared, which equals 9. That's the number I'm going to add and then subtract inside my bracket. So I'll put that down and I'll leave a little room. I'll put in a different color. Okay, so we're going to have plus 9 and minus 9. Okay, keep in mind, folks, that the first three terms make your perfect square. So I write a down, and let's create that binomial squared. So square root of the first, sine of the second, square root of the last. Okay. Or again, shortcuts right here, plus 3. Okay. Don't forget we need to deal with the negative 9, folks. Negative 9 is affected by a, which is negative 4. So that's going to be plus 36. And then don't forget we still have the minus 20 here. Last step, ladies and gentlemen, is to collect like terms. So we go y equals negative 4 times x plus 3 all squared, and then we're going to end up with plus 16. So our vertex, ladies and gentlemen, here, be careful, is negative 3 and 16. Okay, so that's an important part to have to graph, but we also need to know our step pattern. So a in this case equals negative 4. So therefore our step pattern, it's going to be negative 4 times 135. Okay, so that's going to equal negative 4, negative 12, and negative 20. Okay, we probably won't be able to get all those steps on, we'll be able to get a couple. All right, so let's plot this, folks. So we need to, I'll change colors. I'll do this one in blue. Okay, so for our vertex, it's going to be at negative 3 and 16, which is right up. Oh, sorry, one more up. Let me fix that. Okay, so negative 3 and 16. Let me make sure I got it. There we go. Okay, and from that, you're going to use the step pattern as I go over 1 and go down 4. 1, 2, 3, 4. Okay, do that next step pattern over 1 down 12. And that brings me to the origin. Okay. On the other side, I can't do the negative 20, guys. It won't fit. So other side, go over 1 down 4, over 1 down 12. Okay. And I'm going to carefully draw my parabola. Okay. And incidentally, folks, if I'm at the x-axis and I go over 1 and down 20, I'm going to be at negative 20 here, okay, which also matches my y-intercept from my equation. Okay, so this equation, folks, was y equals negative 4x squared minus 24x minus 20. All right, so there's your warm-up, ladies and gentlemen. Let's take a look at our lesson today. Now, to start with, ladies and gentlemen, there's going to be a lot of words. Okay, so I'm going to show you, but I don't want you to panic because this is a key that's going to be important for you to save for next year and for your test and for your exam. Please do not throw this lesson out, ladies and gentlemen. It is important. Okay, and the two strategies I want you to take a look at is the two keys. Okay, number 1. What form of the quadratic is given and what does that tell us? So each form of the quadratic has a specific part of the parabola or a specific type of question that goes along with it. Okay. And the second one is we have to use a toolbox. We have to figure out which equation do we need to switch it for in order to answer the question. So what mathematical procedure to perform in order to answer each question. So we're going to be switching quadratic forms. And when we do that, there's one of two things we're going to be doing. One, if it asks you for the min or the max height, and when it occurs, you need the vertex. In order to do that, there's 3 ways, but the easiest way is to complete the square. Okay? And usually that's because it's given in standard form. However, if it's given in vertex form, you just state the vertex and you know that Q is your min or max value, or your optimal value. Okay, just going to erase that so you can still read it. Okay. Next, ladies and gentlemen, it just as a reminder here that Q is your min-max value. Okay, it's a good thing to have memorized. So that's one question. That's at the top of the problem. We're going to graph this in a minute, and it'll make more sense on the graph if you're a visual person. The second one, folks, is if you're doing a substitution or a solve question. Okay, so you're either going to find the roots, so when did the rocket hit the ground, or symmetry points was when was the rocket at 10 meters. You'd sub in h equals 10 meters, put on the other side, and you would solve. So the only things you do here, this is the same as your last unit, you either factor or use quadratic formula. So here's some examples. When did the ball hit the ground? You're going to sub in h equals 0 and solve. When was the ball at 50 meters? You sub in h equals 50, move this to the other side, collect like terms, and then you should have two answers. Okay, so that's where you're looking for not the zeros, but the points of intersection. Okay, and short form P of I's. All right, awesome. Okay, so folks, I'm going to just take a look at an example of a quadratic and what normally happens. So say a rocket was thrown from a picnic table, so it didn't start on the ground, and it got thrown up in the air, reaches a maximum height, and comes back down. Technically, the other part of the parabola has another zero, but we're not going to be worried about that. Okay, pretend this is nice and symmetrical. I'm actually just going to try and make that a little better. See if I can swoop that a little better down there. That looks a little better. Okay. All right. So based on like a height, a time height graph, okay, if they ask for minimum or maximum values or the vertex, you need to get this into vertex form. So your vertex is P and Q, okay, and to get it to vertex form, most times it's going to be in standard, so most of the time you're going to have to complete the square, which method we just did in warm-ups, okay? Okay, again, it's going to be a maximum if it opens down, it's going to be a minimum if it opens up, okay? But if you need to get to the vertex, you're going to usually complete the square. Okay, that's one aspect, okay? The aspect from last unit that we focused on were the zeros. Okay, when did the ball hit the ground? Okay, so this is what you had, and this was a solve. Okay, so we solved. Okay, and when we solved, we had to either factor or put it into quad formula. So factor or quad formula. Okay, so that's one example of symmetry points, and you solve. Another example that's the same is, say we subbed in, we're going to let the, I don't know, height be 5. As soon as you sub in h equals 5, folks, you've got your zeros here, so you're going to sub h equals 5, and then you're going to find the points of intersection by solving, right? So you're going to find the P of I's, point of intersections, okay, by factor or solve. Usually you're just going to use quad formula to solve that. Okay? All right, and the other important piece of information that we're missing, folks, is the initial value, or the initial height of the rocket, or the initial startup value for a business. Okay, and that is your y-intercept. Okay, and what form do we need there? We need standard form for this one. And in standard form, folks, it is your C value that helps you with that. Okay. All right. So here's the breakdown, ladies and gentlemen. One piece of the information is your y-intercept. That's standard form, so switch things to standard form and look for your C value. Okay? Second most important piece of information is if you're asked for the minimum or maximum values and when it occurs, that's at your vertex. And you're going to be completing the square, because usually it's going to be in standard form. And the other things you're going to be doing is and that's only one solution, by the way. Okay? Those two have one solutions. However, if you're solving, quite often you're going to have two solutions. One, two, if you're doing point of intersections. And when you're finding your zeros, you're going to initially have two solutions. But if the time is negative, you're going to, after you've found both cases, you're going to eliminate or say no or cross the timeout that's negative, because we don't talk about negative time. All right, hopefully that's helpful, folks. We are going to be focusing this on for 2 days, so we're going to take a look at one word problem today, and then we're going to focus on a couple tomorrow in tomorrow's lesson. Okay, let's get started. Example 1, a soccer ball is kicked in the air with a vertical velocity of 20 meters per second. The kick is represented by this equation where h is the height in meters and t is the time in seconds. Okay, so before I even read any question, let's see what we know. Okay, so my hint number 1 was what type of equation was given and what information does that tell us. So what form of the quadratic is this, folks? This is standard. And in standard form, it gives us the what? Y-intercept, which is your C value, which in this case equals 1. So what do you know? The ball was kicked at 1 meter in the air. Okay? All right. So what do I know? I also know that A is negative. Okay? Because A is a negative 5. So that means it opens down. So I'm going to draw a graph. I'm going to start at 1. I know it's going to get a maximum height and come back down. Okay, and this is my time, this is my height. Technically, I'm going to have another answer there for a 0 if I'm looking for zeros. Okay, so focus on a graph, folks. It helps you for a visual. And what do we know? We know that this is at 1 meter that we start at. All right, let's take a look at these questions. A, what was the maximum height of the ball? So maximum height occurs where, guys? At the vertex. So what do we need to do, folks? We need the vertex form, so therefore we're going to do what? Complete the square. Okay? So for A part, I'm just going to add on the diagram. This is what I want. This is my A part. Okay? All right, so let's do this. Okay? So I'm just going to rewrite my equation because I like to have it near me so I can follow the process of it. Please make sure if you're copying it down that you copy it down with the correct values. I've seen a lot of people do an error right away, and then the rest of the question is done wrong, but I'll still give you marks for your process. All right, so folks, remember step 1 for completing the square is to isolate A to the first two terms, so take a negative 5 out. And we have t squared minus 4t, and then the plus 1 is separate. Okay, remember he's not part of the perfect square. Yes, you can take the square root of him, but he's not going to be the one that's going to get us the x minus p squared value. All right, so now we need to do some margin work. Okay, so b divided by 2 equals negative 4 divided by 2, which equals negative 2. And then we got to square that. So negative 2 squared equals 4. That's the number we're going to add and then subtract. So hopefully I can do that now with the same color. Hopefully you guys got that figured out. So we're going to add 4, subtract 4. Okay. So now we've got the first 3 terms in our bracket, folks, as our perfect square. So we can do that. Leave A out front, square root of the first, sine of the second, square root of the last. Okay. And we also have to take care of our negative 4 here. But remember, it's times by A. It's affected by A, so that's going to be plus 20. And then don't forget we have plus 1 left over. Okay, last step is to collect like terms. So h equals negative 5 t minus 2 squared plus 21. What's our vertex here, folks? Our vertex is 2 and 21. So when we go to answer the question, what was the maximum height of the ball? The maximum height is your optimal value, which is the Q part of your vertex. So you're going to say, therefore, max height of ball, this is a pretty high kick, eh, guys, was 21 meters, and it occurred at 2 seconds. Okay, so 2 seconds after it was kicked, it reached its maximum height. All right, awesome. Okay, question B. For how long was the ball in the air? So for B part, we need to find the time when it's down on the ground, which is here. So that's my question for B. So we're going to find a 0. So when the ball is no longer in the air, the height is what? 0, right. So for B, we're going to let the height equal 0. So when we rewrite our equation, it's going to be 0 equals negative 5t squared plus 20t plus 1. And we need to solve this, okay? So remember, folks, when I look here, there's technically going to be 2 zeros. However, we're going to discount that one because it's going to be negative. So we're going to look for 2 answers and we're going to solve. We could quickly take a look at doing product and sum. So product is going to be a times c, which is negative 5 times 1, which equals negative 5. And our sum equals 20. I don't know about you, but I don't know any number that multiplies to negative 5 and sums to 20. So could we in fact factor in this case? No, we can't because there's no 2 possible factors. So therefore, we're going to have to use quad form. So I take about 1 minute to see if I can factor. If I can't, I go to quadratic formula. However, if we've got decimals automatically, you're going to go right to quad formula. You don't have to worry about trying to factor, okay? All right, so just remember, for those who need the help, A equals negative 5, B equals 20, and C equals 1. So let's plug it in the formula. Instead of x, folks, we got t this time. So t equals negative 20 plus or minus the square root of 20 squared minus 4 times a, which is negative 5, times c, which is 1, all divided by 2 times a. Okay, let's go to simplify this. I'm just going to get my fraction looking better. Oh, I'm going to need more room here for sure. Okay, taking a look here, folks. Simplify this out. So t equals negative 20 plus or minus. Simplify your square root. Get your calculators out. You should have 420 divided by negative 10. Now we're going to break it into its 2 cases, the positive root and the negative root. And please make sure you write these down. It's important that you do that, because if you make an error, I can at least give you part marks because you showed me you're breaking them down into the 2 parts. Okay, so plug the first one in, ladies and gentlemen, and you will get an answer of negative 0.05. We know that's the negative 1, so we are going to automatically cross it out. Okay, second one, ladies and gentlemen, is negative 20 minus root 420. Put equal sign and then divide by negative 10. And t equals 4.05. Okay, so don't tell me the time is that. Don't forget that you need to do your therefore statement. So then you're going to say, therefore, ball was in the air for 4.05 seconds from being kicked. All right, give me 1 sec, folks. I got to move this down because we still have one more question to do. Okay, just give me a second here, please. I think we might need a little bit more room than that. Sometimes it's hard to judge. Sometimes my writing is smaller, but I should know better that with these quadratic formulas, these ones take a while. All right, let's take a look at question C. Last question, folks. Stay with me. Here we go. All right. So for question C, it says, for what length of time was the ball over 10 meters? Okay, so ladies and gentlemen, I'm just going to quickly sketch this. We know it started at 1. We know it comes up and comes back down. So we knew our maximum height is 21. We knew it started at 1. Okay, and what we're going to do is it's asking for how long was the ball over 10 meters. So we're going to sub in h equals 10. Okay, and we're going to find out the 2 point of intersections, but to find out how long, we're going to have to take the second time, or second point of intersection, and subtract the first intersection point. So what we're going to do is sub h equals 10 in, but we're also going to be looking for delta t. So we're looking for the change in the time, okay? So I'm just going to put that down so you remember to do that at the end. So we're looking for delta, which is a triangle, delta t. You take the change in the time, okay? It didn't say at what 2 times was it at 10 meters. It said for how long was it above or over 10 meters. Okay, so we're going to sub 10 in, folks. So you're going to have 10 equals 10 for h, right? Negative 5 x squared plus, sorry, t squared plus 20t plus 1. Make sure your t's don't look like a plus sign, ladies and gentlemen. I'm just going to fix my negative sign so it looks like it's separated from my 5. There we go. All right, so we're going to move the move the 10 over. It's going to become negative. And that's going to be, collecting like terms, it's going to be negative 9. Okay, you can quickly do a product sum here, ladies and gentlemen. So product equals a times c, which is positive 45, and sum equals 20. There is not 2 factors that do that, so you can't factor. So we're going to go there for quad form. Okay. So plug it into quad form, folks. We got t equals negative 20 plus or minus the square root of 20 squared minus 4 times a times c, all divided by 2 times a. On the home stretch here, guys. We can do this. Get your calculators out. Plug her in. You're going to have negative 20 plus or minus the square root of 220, all divided by negative 10. Okay. Now we're going to break it into its 2 cases. So we've got one case over here, which is t equals negative 20 plus root 220, all divided by negative 10. So t equals, for that one, ladies and gentlemen, I have 0.52, I think. Yep. Okay. I can't read my writing. That's pretty bad, isn't it? I may have to check that one out myself. Second case, folks, t equals negative 20 minus root 220 all over negative 10. And this one, ladies and gentlemen, is 3.48. Okay, but remember, those are the 2 times that they hit 10 meters on our graph. We want to know for how long was it above it. So delta t equals like t2 subtract t1. So that's going to be our second time, which is 3.48, subtract our first time, which is 0.52. Plug that in your calculator and you're going to get 2.96. Okay. All right, so therefore the ball was at or above 10 meters for 2.96 seconds. All right, hopefully that's a good understanding, folks, of quadratics. Remember, if you're looking, let's just quickly review here. For the first one, max height, you need to find the vertex, which is up at the top, so you need to complete the square. For number 2, when did the ball, or for how long was it in the air, height equals 0, and you solve. And then it asked for question C, for how long was it above 10 meters, you subbed in h equals 10, and then you solved. Okay? Have a great day, folks.